So we're going to continue with constructing our truth tables for our compound statements here. We have this compound statement, this long compound statement right here. And hopefully you can see we have this first clause right here in the closing parentheses, and then we got the second clause here. And then we have this arrow here, so this is a conditional statement. And a conditional statement is an if-then statement. It is made up of an antecedent, so I'm just going to label this as the antecedent. And then it's got a consequent. And I'm just going to label that as C for consequent. So this is thought of as if A, then C. Also, we can see that there are 1, 2, 3 simple statements. So the number of rows of truth values for this compound statement here, don't forget we determine that as 2 to the k power, where k is the number of simple statements. So since there's 3, that's going to be 2 to the third power. That's equal to 8. So there's going to be 8 rows of truth values for this compound statement here. And the way we read this compound statement, since it's a conditional statement, and if-then, this is going to be if R and not P or Q, then R or not Q. So once we construct this truth table, then we're going to use the truth table to determine the truth values of this compound statement, given that P is true, Q is false, and R is false, similar to what we did in the previous example. Again, I'm going to use graph paper or some sort of ruled or lined paper. You should too. It's certainly going to help us keep things organized and neat and clean, especially as our compound statements become a little more sophisticated. So the first thing I'm going to do is I'm going to list all the truth values or standard statements for the simple statements. That's going to be P, Q, and R. You should always do that first. Now the way we fill this out, there's going to be 8 rows to it, is the first half of our simple statement P is going to be true. So that means the first 4. And then the second half, the next 4 are going to be false. Same idea for Q, except rather than 4, it's going to be 2. We wind up having it. So this will be the first 2 are going to be true, and then the next 2 will be false. So we cut the pattern in half. Again, we cut the pattern in half, or in other words, we wind up just alternating it for the last simple statement. This way it keeps it nice and tidy as we fill out the truth values here, because there's a myriad, dozens and dozens of ways of being able to correctly fill out these truth values. But as the compound statements and the number of simple statements become a little more complex, it can get very confusing very quickly on how to fill this out. So this chapter sticks with a pattern, and that pattern is what we just demonstrated. The first half of the first simple statement is going to be true. Then we cut that pattern in half for the next simple statement, and we keep cutting it in half for each successive simple statement. So if you do this successfully, your first row of simple statements, or truth values I should say, should be all true, and then the last row of the truth values should be all false. And again, we're going to stick with this pattern throughout this chapter. So now that I have that, as I go over here, I'm going to work within the parentheses first. And the innermost parentheses we'll target first. So you can see right here we've got not P or Q, and right away I could say I have a not P. And coincidentally, I also have a not Q. So since obviously we're going to need both of these, I'm just going to list both of them right away. I'm going to put in not P and not Q. And of course, the negation turns a true statement into a false statement, and a false statement into a true statement. So this winds up being the first half are going to be false, and then the second half are going to be true. Same idea for not Q. We change a true statement into a false statement, and a false statement into a true statement. Now I'm going to go ahead and construct this clause right here, not P or Q. This is a disjunction. This is an or. For this entire clause to be false, both of these statements have to be false. So what I like to do is I like to look at just the falses here. Since this has to be false and this has to be false for the entire thing to be false, I like to speed up my work a little bit. So I'm just going to go to the falses right here and look for where Q is also false. It isn't there, not there. It is right here, false and false. So this is false. And it is right here. Other than that, it's going to be true. And you can see where the graph paper helps in keeping everything organized. Nice and neat. Next, we're going to do inside the parentheses here. We're going to expand it. So this is going to be R and not P or Q. This winds up being a conjunction. This is an and. So for this entire clause to be true, for a conjunction, this has to be true, and this has to be true. So what I like to do is I'm just going to go to the trues right here. Just look at the trues. And then see where it's true for R. So it's true here, and it's true here. That's true. It's true here. It's false here. It's true here, and it's true here. So that's true. It's true here and false. True here and true here. And I think that's it. Other than that, the rest are going to be false. It's just a clever way of being able to speed up listing all our truth values. The next thing I'm going to do is I'm just going to go ahead and I'm going to build this clause now. I already have my not Q. So I'm just going to go ahead and say R or not Q. Again, this is a disjunction. This has to be false, and this has to be false for the entire clause to be false. So I just kind of focus in on the falses. So I've got a false here and a false here. So that's false. I've got a false here and a true, so that doesn't work. I've got a false here and a false here, so that's false. And I've got a false here and a true, so that doesn't work. So the rest are going to be true. Now finally, I can put together the entire compound statement, which we've already determined is a conditional statement. So I'm going to pen that all in. If R and not P or Q, then R or not Q. For a conditional statement to be false, the antecedent right here has to be true, and the consequent right here has to be false for the entire compound statement to be false. So I'm going to go to this right here and look for the trues and then see if I could pair them up with the falses of the consequent here. So this clause right here, here's its truth tables. And for this clause right here, here's this one. Now the arrow, the direction of the arrow matters. Antecedent points to the consequent. So I've got a true here, but it's true right here. I've got a true here, but it's true right here. Don't forget, I'm looking for a true false to mark it false. It's just a convenient way of speeding things up. And then I've got a true here and a true right here. So I have no true falses to label as false. So all of these are going to be true. This is all going to be true. So the question is, use the truth table to determine the truth values of this compound statement. This is it. Here's the truth table for it. Given that P is true, Q is false, and R is false. Well, right here is where P is true, Q is false, and R is false. I'm just going to put an arrow and point to it. But since everything is true anyways, we could easily see, and we're just going to go scroll right over like this, that it's going to be true. So what does that mean? Well, for this compound statement, within this compound statement, when the simple statement P is true, the simple statement Q is false, and the simple statement R is false, the compound statement is true.